Welcome to Maths with Paru. This question is from Cambridge IGCSE Extended 0580, November 2021, paper 43. Let's begin. The first question is on transformations. So here we have the first question, which is describe the transformation from T to A. Now, we can use tracing paper. We can also use the perpendicular bisectors of corresponding points, this line and this line and this line, to find where they meet, which is 5, 2, and that is your center of rotation. And T moves clockwise 90 degrees onto A. Now, part B. Describe the single transformation from T onto B. So here we go 1 in the negative x direction, 4 in the positive y direction, and so our translation vector is -1, 4. Next question is to find the distance that T moves when it goes to B. So we are talking about this length of the line. We can easily say that we can use Pythagoras theorem to find that. So c squared is equal to 1 squared plus 4 squared, which is 17. And c is the square root of 17, which is 4.12. Next question is part 2, question 2, part A. It's angles in circles. You have a circle here and you have this triangle, AOB. Angle B is 38. AOB is an isosceles triangle since AO is equal to OB, which is the radius. Now they're asking for ABB. If I name it X, then the angle at the center is 2 times x, because that's the theory for angles in circles. Angle at the center is twice the angle in the remaining segment. So here in triangle ABO, we have 38 plus 38 plus 2x is equal to 180. Because angle A is equal to angle B, since it's an isosceles triangle, we can solve for x, which is 52 degrees. 2b, we have a cyclic quadrilateral, CDEF, and we're asked to find EFC. Now, we're given that TCU is a tangent. We know that angle between the tangent and the chord, 50, is equal to the angle subtended by the chord, which is 50. That's the alternate segment theorem. Now, remember that it's given that CF equals FE. It's an isosceles triangle. If this is 50, this is 50. The missing angle is x. We know that x plus 50 is 180 because it's a triangle. Therefore, x is equal to 80. This should be not equals, this should be plus. Now the next one is angle CDE. CDE. If you look at this cyclic quadrilateral here, opposite angles of a cyclic quadrilateral at 180. So if this is y, x plus y is 180, y is equal to 100. Moving on to question 3a. The first question is they've given us this prism and they have said that this is 5. They have said that also that CD is parallel to an AB. CD is parallel to AB and AC is equal to DB. So that helps us to know that this is an isosceles trapezium. Now the question they're asking is to calculate the mass of the prism. Now first we're going to find the volume of the prism. The volume of the prism is the cross-section area into, they've given us the volume of the prism, so we don't have to worry about it. But they're asking us for the weight. Now, the volume is 525 centimeter cube. 1 centimeter cubed has a mass of 7.8. So 525 centimeter cubed has a mass of 7.8 into 525, which is 4,095 grams. And the answer is asked in kilograms. So it's 4.095 kilograms. Moving on to the next part of the question, they say, to calculate the length of the prism. Now we know that the volume is cross-section area into the length. The cross-section area is a trapezium. That is half of 4 plus 10 into 5 is the cross-section area into the length is equal to the volume. So when we work it out, we find that the length is 15. Then we move on to question 3A, which is calculate the total surface area of the prism. Now, if you look at the surface area of the prism, we have a trapezium in front, a trapezium at the back, we have a rectangle at the bottom, a rectangle on top, and we have two rectangles on either side. If we add them all, we'll get the total surface area. Now, to begin with, to get this length dB, we have to find it using Pythagoras. Now, we know that these two are parallel, so if this is 4, if you drop a perpendicular, this is also 4. So therefore, we know that this entire length is 10, and these are isosceles trapezium. Therefore, if this is 4, this has to be 3 and 3. Now, we want to find out x. X squared is equal to 5 squared plus 3 squared. X is equal to 5 squared plus 3 squared, which is 34, and so we have that x is equal to the square root of 34. All right, then we're going to use that to find out the area of this trapezium. The trapezium we know is half of 4 plus 10 into 5. There are two trapeziums, so you multiply it by 2, we get 70. The bottom rectangle is 10 into 15, 150. The top rectangle is 4 into 15, 60. The two side rectangles are 2 into x into 15, which is 2 into root 34 into 15, which is 174.9. If we add everything that is in boxes, that is 70 plus 150 plus 60 plus 174.9, we end up with 454.9 centimeters squared, which is the total surface area. Now, part 4 of this, you have a mathematically similar prism. Height of a trapezium is 10 centimeters. Calculate the volume of the prism. We know that V1 over V2 is L1 over L2 cube. The first trapezium is 525 is the volume. The second trapezium we don't know. The first trapezium has a height of 5. The second trapezium has a height of 10. If you divide 5 by 10, you get a half. Half cubed is going to be 1 over 8. So we multiply V2. If we cross multiply, V2 is equal to 8 into 525, which is 4,200. Now, the next thing they have is they say a cuboid measures 10 by 4 by 6. Each side is measured to the nearest centimeter. Complete the inequality for the volume. That means here they've given the volume and you are required to find the least volume and the greatest volume. Now, since everything is to the nearest centimeter, we can add or subtract a centimeter divided by 2, which is half a centimeter. So to get the least volume, all the measurements are reduced by half a centimeter. So that means you get 9.5 into 3.5 into 5.5. And that's what I've written here. To get the greatest volume, we add half a centimeter. So you get 10.5 into 4.5 into 6.5, which is what I've written here. And those are the values that go on either side. I shall end this video now, and then I shall continue with this paper, question 4 onwards. So that's all for now, up to question 3, 2021, paper 43, 0580, syllabus extended, Cambridge. Until my next video, goodbye for now.